You all can participate, right? First question we have, which of the following figures represents an inconsistent system for two linear equation? So when you have two parallel line, the system is inconsistent. The system is okay. 1 minute. I think I have to change the sound, or else the sound will be going to wait. I'll have to record it again. Speaker. That's right. Okay, so yeah, the first thing, now this is inconsistent and there is no solution, right? No solution. This is called parallel lines. Yep. Any problem in this? No. Now let's talk about these options also. First option, you have one intersecting point. So how many solution? System is consistent or inconsistent? System is dependent or independent? That you will have to remember now. Okay, we have discussed it so many times, so remember it. Similarly here, if you look at option C, it is also intersecting at one point. So one solution, consistent and independent. Alright. Now last option which you see here, option D. Tell me about this one. No, this is not parallel. Yeah, B is the parallel. Here also one solution, because if you extend them, they will intersect at some point, right? They will intersect at some point. So there is one solution. Consistent or inconsistent? Inconsistent. Boys, if you have a solution, the system is consistent, right? Now, if the system is consistent, then it will be dependent or independent? This one is independent. If you have like this, there is one solution, consistent, independent. All right? One solution, consistent, independent. Okay? Now, what if you have a line, let's say, and on the top of it, coinciding line. We call this as coinciding line. Many solution, right? Dependent, okay. And come on, consistent, right? So if you have a solution, the system is consistent, right? If you have a one solution, many solution, the system is if you have no solution, the system is inconsistent. Solution, consistent. No solution, inconsistent. All right? Okay, let's move on to the next one. Yeah, the parallel is already done now. The question number 2. Now let's read the question number 2. In which region of the graph is the solution to the system found? Now, first of all, to solve such problem, what you have to do is step 1. Anybody would like to tell? Change it to y equal mx plus b form, which he said it right. Change it to slope intercept equation, right? M is the slope, b is the y-intercept. Yes? Now, one more thing that you need to remember, if you have a less than or more than sign, the line is solid or dash line? There will be a dash line. If you have a less than or equal, more than or equal, what kind of line you will get? Solid. This is your solid line and this is your dash line. Okay, so now you guys try it. I'll give you 5 minutes, and until then I'll pause the video. You try and let's see what's your answer. Okay, let's continue. So your answer is, anybody would like to answer? Yep. 1. Okay, so now let's check if the reason 1 is our answer. First of all, y less than, right? So I'm just putting equal x minus 1. There is no problem in this line. The second one is negative x plus 2y less than or equal 1. If you change it, that will go that side. 2y less than or equal x plus 1. Now you divide with 2. So y less than or equal x over 2 plus 1 over 2. Right? This information will help you to understand if in the option you have same type of options, then it will help you to determine y-intercept and the slope. So you can find out which one is exactly your answer. If you have like 4 or 5 option, you might get confused. So this information will be useful to find out which option is the correct one. Okay, and then you can check the shading, which I'll come to that. So that's your first step. Now in this question, even if we don't do this, we can still solve it. So next step is step 2. This is your less than, right? Now this is a dash line, right? A dash line which will be passing through minus 1. Dash line passing through minus 1. Yes, this is correct. This is a solid line passing through 1 over 2. Solid line passing through 1 over 2. So this is correct. Any problem in this? Yes. How is it going up and down? 1 second. Okay. Now let's check the slope. The slope here is positive 1, so it will go up. Similarly here the slope is 1 over 2. This will also go up, but 1 step up and 2 unit right. That's how we have studied this, right? Also, so this is your equation 1. Now this is your equation 2. Why did we do this? Because we want y equal mx plus b form. Okay, that's why we changed both the equation. All right. Now step 2 is test point. Test point, you can take any point. Usually we take 0 comma 0. Okay, so now check for this. For a dash line, the test point 0 comma 0 is here, right? 0 comma 0 is here. Now y less than x minus 1. Y is, this is x, this is y. Y is less than, x is 0 minus 1. 0 less than minus 1. Is this true or false? 0 less than minus 1. Is this true or false? It's a false. 0. Okay, this is 0. Negative numbers, negative 1, negative 2, negative 3. Positive number 1, 2, 3, 4. Right? So negative 1 is a smaller number, so false. If this side is false, then you will shade the opposite side. Right? Yes? Okay. Now let's talk about point number 2. So now I need to clean up the space because I don't have enough space here. Okay. Now let's write equation 2. From equation 2, y less than or equal x over 2 plus 1 over 2. Right? Y is 0. X is 0. I told you the test point is 0 comma 0. That's what I'm taking. When you take a test point, take it for both the equation. Not like here you take something else and then something else. Okay? So that is 0. 0 plus 1 over 2. 1 over 2. Right? Or you can write 0.5. So 0 less than 1 over 2. Is this true or false? True? Good. So if this is true, the point was here for the solid line. This is true, right? Now we are looking at the solid line. So this will also shade. This is true. This is the solid line. Look. This is the solid line, right? This point is true here. So if this side is true, you shade this side. If this side was false, then I will go opposite side. Okay? Cool. So this side is true for this, so I will shade this side. Now tell me where the green color and the pink color are. One second. Yeah. Where the green color and pink color are. Yeah, no problem. That depending how you want to shade, right? This was true, shade downside, and this was false, so downside. So what's your answer? Somebody said reason 1. So overconfident people suffer like this when they know everything, okay? So your solution is only this part where you have a common thing, okay? In the exam, if you shade like this, it will look too sketchy, it will not look good. So arrows will show the direction where do we need to shade, okay? Or else they will give you a graph paper. Got it? Where is the solution? Reason 2. Where is the solution? 2. Because green and pink both are intersecting, right? If I did any calculation mistake, check it by yourself, okay? That's the process. Cool? Good. Now next question, let's move on to the next question. Now the next question says use substitution to solve the system of equation. So you guys try, I'll give you 5 minutes. Okay, question number 3 is about method of substitution. So you will substitute y value here. So this is your equation 1 and this is your equation 2. Substitute equation 1 value into 2. So x plus 5, y is x plus 1 is equal minus 1. Solve it, x plus 5x plus 5 equal minus 1. X plus 5x will give you 6x. Take the 5 other side will be equal to negative 6. This is plus 5. Other side you will take minus 5. So minus 5 minus 1 minus 6. Right? Divide 6. X is equal minus 1. X is equal minus 1. Now you have to find the y value. Substitute in equation 1. From equation 1. Y is equal x plus 1. Y is equal minus 1 plus 1 is 0. So your solution is x comma y. X is minus 1, y is 0. That's your answer. Now the question number 4 is about elimination, because here the number is same, so you can eliminate using addition, right? So if one number is positive, one number is negative, you will use method of addition. If both number have same sign, for example negative 5 negative 5, then you will use subtraction. If both number is positive 5 positive 5, then also you will use subtraction, okay? That I've discussed already, but here you will use method of addition. So plus 5 minus 5, when you add, cancelled out. 3 plus 5 will give you 8x is equal 11 plus 5 16. Divide 8, x is equal to. Now from any equation you can take, let's say from, this is equation 1, equation 2. So from equation 1, 3x plus 5y is equal 11. So 3x, x is 2. Let's substitute the value here. So 3 times 2 will give you 6 plus 5y is equal 11 minus 6 both side. 5y is equal 5, right? And that is divide 5. Y is equal 1. So your solution is 2 comma 1. Solution is 2 comma 1. Now the last question we have, in order to solve the system of equation 1, equation 2, using the method of elimination, what do we start with? Okay, now here, is this number same? No. Is this number same? No. So when the numbers are not same, we use method of multiplication. Yani means what we do is we have to multiply with a number where we can make them same. So if you see here, this is 2. Can I make this 2 here? So if I want to make this 2 here, I will have to multiply this equation with 2. So that will be 2x. This will also be multiplied with 2. This will also be multiplied 2. So basically what you are doing is you are multiplying the whole equation with 2. So that will become 2x plus 10y is equal 4. That's how you do it. So your first equation is, let me write here, 2x plus 7y is equal 1. The second equation will be 2x plus 10y is equal 4. When you multiply equation 2 with 2. That's it. That's how you do it. Now here if you look, the numbers are same, so you will use method of subtraction then, right? 2 and 2 0, and then you can further solve it. So it's only asking where do we start. So we start with multiplying equation 2 with number 2. So we can make one one variable with the same coefficient. Okay, so that's it. That's it for this video. That's the revision of system of equation. I hope that will help. Good luck.